Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Welcome. This is Mr. Simon, and we are going to be studying Senior 5 Chemistry. And we are using this chemistry to change our lives. So today we are going to talk about electrolysis, and we are on lesson number 2. So we are going to look at the electrolysis of different electrolytes. So the aim of this lesson is, by the end of this lesson, students should be able to explain the electrolysis of different electrolytes. Like last time we said, we had looked at the definition of the term electrolyte. Who can define for us the term electrolyte? So electrolyte is substance which conducts electricity both in molten and aqueous state. So the first one today, actually, we are going to use the other principles we talked about last time to explain the electrolysis of different substances. So we had different factors we talked about last time. Factor number 1 was the electrochemical series. Second was concentration. Third, we talked about the type of electrode, and also we talked about the different states of our electrolytes. So we are going to use those principles to briefly explain, or in details, to explain the different types of electrolysis of our electrolytes. So the first one we are talking about today is acidified water. In acidified water, actually, we have two ions, as you see on your screen. We have the H plus and the OH. And the what? The OH. So as we saw last time, we saw that the anode is positively charged and it will attract the OH, and the cathode is negatively charged and will attract the H plus, as you see on your screen. So, meaning at the anode we shall have an observation, we shall have production of oxygen gas. And the cathode we shall have an observation, and we shall have production of hydrogen what? Gas, a gas that burns with a pop sound. Actually, this electrolysis is applied in the industrial large-scale manufacture of hydrogen gas. You know, hydrogen is very important. It finds very many applications in our daily life. So when you're carrying out electrolysis of acidified water, it is an application. Of large-scale manufacture of hydrogen what? Gas. This type of electrolysis is very simple because it has only two ions. So we have a simple illustration you can see. Normally, we have some observations. What is happening both at the anode and the cathode, or the positive plate and the negative what? Plate. So you see at the cathode, we are having hydrogen, bubbles of hydrogen gas. And at the anode, we are having bubbles of oxygen what? Gas. So we can collect these gases. Using another system, and we use them for other purposes. So as we continue, so we are going to talk about again electrolysis of sulfuric acid. Acid. So here, if you look at sulfuric acid here, in sulfuric acid, we say here we have actually ions present. So if it is dilute, or we say aqueous, obviously we shall have water inside. And so the ions, we shall have the H plus from water and from sulfuric acid. Then we shall have the anions, which is the sulfate anion and the OH. These are the ions present. As you look at your screen, you can see those things very well. So you see here, we have 2 negatives and 1 positive. So meaning that at the anode, at the what? Anode. The ions which will be attracted at the anode will be the negative ones. So we have the sulfate and the OH. Sulfate and the what? The OH. So both of these move towards the what? The anode. We can have a simple illustration here where we have a beaker. So we have our. So I'm trying to show a simple electrolytic cell which we can do in the laboratory. So when you go to the lab, we shall try to see how this happens. So it's an illustration. So we connect, these are electrodes. So we connect, these electrodes are supposed to be in a substance which allows electricity to go through. But this time, because we are in general electrolysis, we are going to use either platinum or carbon. So we have something like this. So this one will be the anode connected to the positive, and this will be the cathode. So we say this is the anode, and this is the cathode. And that is the what? The cathode. So here we recognize that these two will be attracted here. We can illustrate using, maybe we already have negatives. So these ones here. So we shall have sulfate and the OH. So, but we are saying that for the chemical reaction to take place here, we consider the other first law we talked about, where we look at the position, the electrochemical series. So we observe that OH is lower in the electrochemical series, and therefore it will react fast. To react what? Fast. So we say it will undergo the chemical what? Reaction. And this one will be left in what? In solution. So we shall have 4. You can say 4OH if you know how to balance this equation. So it will give us water as one of the products and oxygen as the chief one, because it's the one which shows the observation. So as we balance the ions, you recognize here we have 4 times negative. So there are 4 electrons, or we can say 4 negatives. So for us to be able to balance, we put 4 electrons. So as we saw last time, this anode we have oxidation, where this time oxidation is the giving away of what? Electrons. Giving away of electrons. Then we have our cathode. At the cathode, we call it the negative plate. So it will attract the positive. At least these ones we can illustrate them. Attract the what? The positives. So, meaning at the cathode we have only H+, and H+ will undergo this reaction. So who can tell us what we can produce? Yes, we are going to produce hydrogen. We're going to produce hydrogen what? Gas. So aqueous. So this is what why we say that when you're carrying out this electrolysis, you need to see bubbles. You need to see bubbles. So bubbles on both the anode and the what? And the cathode. That is the observation. That is the observation. So we continue. Hope you are following. We have a simple illustration. Have a simple what? Illustration. This time we have used actually pencils in our illustration, where we have, in pencils we have this graphite. So one of the uses of graphite is making of pencils. So you recognize that in those pencils, if there is graphite, we can use them as So if you are using them as electrodes, again, you recognize that at the positive plate we have oxygen and the negative plate we have what? Hydrogen. So that is a simple illustration. So when you're carrying out this electrolysis, you always supposed to produce these two gases, unless when there is a mistake in your work. So we have another illustration here. Again, electrolysis of sulfuric what? Acid. Yeah, you see, now we have another system. In a way, we can collect our hydrogen and oxygen. We can collect them and then we test them. Like oxygen can be tested using, who can tell us how we can test oxygen? So we can test oxygen using a glowing wooden split. So when it lights, you know that is oxygen, and for hydrogen, it will always burn with a pop sound. Yeah, so that's another illustration of electrolysis. So let's continue, and we talk about electrolysis of sodium hydroxide. Sodium what? Hydroxide. Sometimes this is called the caustic soda. Caustic soda. So in sodium hydroxide, as you see, the ions here, because it is aqueous, we shall have water. So our ions present, the ions present will be, we have the OH from sodium, we have also sodium. So this OH comes from sodium and water. Then we have also the H plus. So then we look at the anode. You look at the anode, the positive plate. The anode will attract only OH. And our equation will be similar to this one. Yeah, so we can copy it very quickly. So we say 4OH, 2 water plus oxygen plus 4 what? Electrons for balancing. 4 electrons for what? Balancing. Hope you are enjoying and you're understanding what we are doing. So then the cathode. These things are somehow easy to understand. If you recognize the charge of the anode and the cathode. So here at the cathode we shall have 2 ions attracted. 2 ions what? Attracted. So those 2 ions we shall have competition. And during that competition we say we choose the ions which is lower in the electrochemical series. As I told you last time, when you have the cathode, the competition will be between those 2 positives, either sodium or hydrogen. That is the atom and the hydrogen. So the competition now is won by hydrogen because it is lower in the electrochemical series. So we are going to produce again hydrogen what? Gas. So we can put even states. There is no problem. It is nice to put them there. Put gas, and here we have what? Aqueous. So electrolysis of acidified water, electrolysis of sulfuric acid dilute, and the one of sodium hydroxide are giving the same products. Products. So we quickly continue. And we talk about the electrolysis of copper sulfate. Last time we tried to pass through this. So we have a simple illustration. Simple what? Illustration. So this type of electrolysis, we are going to discuss it using different electrodes, because whenever we change the electrode, the products at the anode and the cathode will change. The products at the anode and the cathode will what? Change. So for example, so now we are on copper sulfate. Copper sulfate. Hope you are following. Make sure you follow what we are doing. So copper sulfate, we said you're going to divide into two parts. One part, we talk about using platinum or let's say graphite. So we call these ones the inert electrodes. Inert electrodes. Actually, all here we are using the same. So even these ones are made out of platinum or what? Graphite. So, as you recognize very well, we say here we have the anode, and we also have the what? The cathode. And I know now you are an expert, you can easily tell the ions present, but let's just write them here. Just for a simple illustration. Simple what? Illustration. We have copper 2. We have the sulfate from copper sulfate. Then we have H plus and the OH from what? Water. So at the anode, we shall have attraction. Attraction of the negatives. That's the sulfate and the OH. Then at the cathode, we shall have the positives. We have copper and what? H plus. So who can tell us at the anode which one will react first? Which one will react first at the anode? Yeah, it is OH. Yeah. Why? Because we say because it is lower in the electrochemical series. So again, we are going to say our reaction. Yeah. We are writing this one very much, and we want you to get it in your head by the end of this lesson. So we have oxygen and plus 4 what? Electrons. So again, at the anode, we shall have bubbles. We shall have what? Bubbles. If you see in our small diagram at your screen, you can see some bubbles. Some what? Bubbles. Then at the cathode, this time we have competition between the copper and the hydrogen. So copper and hydrogen, which one is lower in the electrochemical series? So the one which is lower in the electrochemical series will react first. So it is obviously copper. So copper will be deposited. Copper will be what? Deposited. It will be deposited at the cathode. So you recognize that if we have a small illustration here, small illustration, let me do it here, very small. Our small electrodes here. So something will be happening at both of these electrodes. So one of them here at the anode, we shall have bubbles. We shall have bubbles. Then at the cathode, because we have a deep deposit of copper, it will increase in size. Increase in what? In size. So those are the observations. So again, now we're going to talk about, there is a small comment there saying, comment about the pH of our solution as electrolysis continues. As electrolysis continues. What happens to the pH? So you observe that during electrolysis, as OH goes away and the copper goes away, what shall we remain with? We are going to remain with the hydrogen. So we are remaining is the H plus and the sulfate. So these two, you recognize that they can form sulfuric what? Acid. And sulfuric acid is an acid, obviously. And you know the pH of acid is always below 7. So we are going to say the pH. So our comment will be the pH. You can say pH decreases. pH what? Decreases. Why? Because sulfuric acid remains, or we can say is formed. We can say remains. So remains. So you observe that remaining with sulfuric what? Acid. So quickly, let's talk about electrolysis of copper sulfate using copper electrodes. Copper what? Electrodes. So we can say now we are on copper sulfate and we are going to say using copper electrodes. Using copper electrodes, we sometimes call this one the reactive what? Electrodes. So using copper electrodes, we have, you can see on your screen, we have a simple illustration. So we say, we are going to say ions, we already know them, so we can say what happens at the anode and what happens at the what? The cathode. So at the anode, we have both. What do we have? We have OH and what? And sulfate. Then at the cathode, we have copper 2 and the H plus. So we recognize that this equation at the anode changes. So the competition now is not even considered, as we talked about it last time. So instead of these ones taking place in the chemical reaction, we say copper dissolves. Copper what? Dissolves. So the copper, the anode will be what? Dissolving. The anode will be dissolving. Then the equation at the cathode remains because the competition here. So here we have a factor. The factor of the electron is affecting the product at the anode. But this one, again, it's the normal competition. It's normal what? Competition. So we shall have copper being deposited at the cathode. Yeah, at the cathode. So those are the differences in our electrolysis. So if you look at our diagram, it is trying to illustrate what is happening. If you look at it very well, recognize that now this copper anode is breaking down. It's breaking down. So as it breaks down, some of it will be deposited here. Deposited what? Here. So as it is deposited there, so you observe again, we shall have increase in the size of the cathode again, and decrease in the size of the anode. So we have simple question here, which can help you to understand what we are doing. It's saying give the differences in the observation when copper sulfate is electrolyzed using the copper electrode and the carbon electrode and the copper what? Electrodes. So we can make a small illustration here that electrolysis of copper what? Sulfate. So the differences in the observation. Differences in the observations. Differences in what? Observation. So we have here, we have the copper. Can talk about the, let's begin with the using the carbon electrodes. Carbon electrodes, or which is graphite or platinum. Then here we have also using the copper electrodes. Copper what? Electrodes. So I hope you are following and you're enjoying what we are doing. So you're going to give me the differences in the observation. The difference in the observation. So we can try to talk about some few of them. So the first, we can look at our anode. Yeah, here we can say no change in size of the anode. Anode does not change in size. Then here, using copper electrodes, you say anode decreases in size because we said it breaks down. Anode decreases decreases in size. So you see? Yeah. You see now these differences. You see here anode is not changing. While here the anode is what? Decreasing. So who can give us another difference in the observations? Difference in the observation. Yeah. So we have another difference. If you look at this one very well, you'll observe that here at the anode we have gas given. So here we say bubbles of a colorless gas. You can say bubbles. Bubbles of a colorless gas. Colorless what? Colorless gas. Bubbles of a colorless what? Gas. At the cathode. Is it a cathode or anode? Not cathode. So let's say it is actually the anode. The anode. Then here, no bubbles. No bubbles evolved. No bubbles what? Evolved. So you see the difference, copper electrode, no bubbles, because the anode breaks down here bubbles. So you're going to give me more differences. I need like 4. So you complete that table, and you look at more what? Differences. You can discuss about those differences. Yeah. So as we continue, so as we come to the end of our lesson today, we are actually going to discuss about, I'm going to leave you with an assignment, and you be able to discuss or try to do this assignment or exercise, a simple question. So it's about electrolysis of copper sulfate, where they are asking you to sketch and label an apparatus that can be used in such an experiment. Then write the equation that occurs at the cathode. We have done that one. You try to look at it. Write the equations of reaction at the anode. What happens to the pH of the solution as the electrolysis proceeds. So you see this first part of our question is about electrolysis of copper sulfate using platinum what? Electrodes. Then again, if we change, so part E of our assignment or our exercise is actually this, what we are trying to illustrate here. What we are trying to what? To illustrate. So, make sure you do that assignment. And we shall meet next time. Hope you've followed me very well and you've got what we have done. God bless you very much. See you next time.